So the format for today will have them give short, brief talks about 5 to 7 minutes, give or take, and we'll have them present it back to back. And then after they've presented, we will lift the giant movie screen and open it up for discussions across the talks or individual questions that you have for any of the presenters. So we'll welcome up Matthew Kay as our first lightning talk.
Thank you. Okay, so hi, it's wonderful to be here. Just a little bit about me. So I actually grew up just across the border in Canada. I did my master's and bachelor's at the University of Waterloo. Went over to Seattle and forgot how to live in the snow for about 6 years, and now I'm back over here. I do work in HCI visualization, sort of design and statistics. So I'm just going to give you a really quick overview of a couple of the threads of my work. I've done work in personal health sensing and feedback. So this has been on trying to help people improve sleep in the home or track sleep in the wild, track fatigue. I've recently been doing a chunk of work on communicating uncertainty in sensing and prediction because most of the ways that we do that are pretty bad and people don't really understand the error in the data that they're looking at. So I've done this in kind of weight scales. I've done it in transit prediction, so trying to figure out when your bus is going to show up, for example. And I've done some work looking at how acceptable people find errors in these types of systems. I'm also really interested in improving statistical communication in HCI and visualization. So I've done some work on that in InfoViz, and I recently had a paper at Chi advocating for a shift to Bayesian estimation over null hypothesis significance testing in the field. So I'm going to really quickly talk about two of these at a fairly high level and really just skimming through. So in the transit prediction example, let's say you're waiting for a bus. This is a real-time tracking system. It tells me I'm waiting for bus number 120 and it's going to show up in 11 minutes. There's a lot of error in this estimate and I might want to know if I have enough time to get coffee. Well, this is essentially what the system is telling me right now. What might be more useful is a probabilistic estimate, so how early or late could the bus come, based on what we know of where it is and how much error is in those sensors and so on. Skipping a whole bunch of details. You can come up with more intuitive ways of visualizing this type of probability by using sort of discrete outcome plots. This is one that I developed that has the nice property that intervals correspond to a simple counting procedure. So if I'm interested in what the probability is that my bus is going to show up in 8 minutes from now or later, well, if I know there's 20 dots here, then it's 18 out of 20, so the number on this side, or just a 2 out of 20 chance that I'm going to miss my bus. So this is trying to take a sort of abstract probability, make it concrete, and help people reason about it. And this also, so this type of technique improves the precision that people have in their estimates of probability intervals in this type of task by about 15%. So that's that in 2 seconds. So, usable statistics. Everyone's talking about the replication crisis. Science is failing all around us. A lot of people are talking about how social science is not replicating. A lot of classic results in social science aren't replicating. Statisticians are telling you what you should be doing in your papers and in your analyses. And a lot of this, from an HCI perspective, sounds like blaming the users. If your tool spits out tables of p-values, that's what you put in your paper, and that's what you get. And that leads to all of these other problems. And so what I'm really interested in is, rather than just saying, well, statisticians will tell you what to do, here's a list of things, you should do them, what are the tools that we can build to actually help people do those things by default? So that's a chunk of work that I'm looking at moving forward. So things like, what would usable statistical tools look like? How does your junior grad student translate research questions into statistical questions? How can we guide that process to something a little bit more rich and nuanced? And move people away from binary hypothesis testing to estimating effects. So if you're thinking about this from an HCI perspective, if you run a study and you're comparing two techniques, and you want, say, a p-value to try to figure out, oh, is one better than the other? If you give me that study and I give you 100,000 users, I will give you a p-value that's less than 0.05. it's not telling you the thing that you want to know, which is how big is the difference, how reliable is the difference, and do we care? Okay, so that's the 2-second version of 2/3 of my work. Really what I'm interested in is that the apps that you pick up communicate uncertainty to you in a way that you understand, that's relevant to the goals that you have, and that the statistical tools that you use do the same, and that they guide you to answer questions in a way that's more effective and more useful. That's it. All right, well, it's my pleasure to be here. Not as a job candidate, but actually a faculty member. So I'm also one of the new assistant professors in the School of Information. Before I joined here, about a month ago, I got my PhD at the University of Ulm in Germany, and I spent the last 2.5 years at CMU as a postdoc. And at some point in my life, I also spent some time at Deakin University in Australia, as well as the University of Twente in the Netherlands. So I've been kind of all over the place. So is my research in some sense, but it's also somewhat coherent, as I hope to convey to you. So I'm really at the intersection of human-computer interaction, privacy and security considerations, as well as novel technologies, particularly ubiquitous computing, Internet of Things, things like that. I'm interested in understanding privacy and security decision-making. What really drives decisions? Why do people make bad decisions? How can we build technologies and solutions that help people make better decisions and manage their privacy more effectively, or security, as well as building privacy protective and secure systems that underlie that, but also leverage novel technologies to build cool and interesting and meaningful applications. So it's just going to be a quick overview of my work, and it's going to be a bit broader than, for example, my job talk, just to give you an idea of what kind of person I am and what kind of research I do and I'm interested in. So the one thing I already mentioned is understanding privacy decision-making. And this really relates to how do people reason about privacy? Do they even reason about privacy? And how can we support this on different layers and different phases of the decision-making? One aspect we look at here is privacy expectations and concerns. And what we find is that concerns and expectations really vary by context. So this is a study, without looking at this in too much detail, I need to talk to Matthew about how to present this in a more usable way. but basically what we found here is that privacy concerns and expectations vary based on what kind of websites you visit. And we can leverage this. So we use this, for example, to simplify privacy notices. On the left, you see Fitbit's privacy policy, which is very difficult to read. And then these are short versions of the privacy notice that we created. And you can see that they get progressively shorter, and that is, we remove those data practices that are expected by a majority of the people in our studies. And what we find is that, particularly for the middle notice, by removing certain practices from the notices, there's no negative impact on the awareness. So people still are aware of all the data practices. When we go to the short notice, it becomes troublesome. There are just not enough notices in there. So that's interesting. That's some work we're going to go forward with. How can we leverage expectations, knowledge about expectations, to better tailor information around privacy as well as security. Another aspect we look at is nudging users to make better decisions. The idea here is to leverage cognitive biases, for example, as well as combating asymmetric information or decision heuristics to help users make better decisions. And here we conducted a field study with Android users where we showed them these messages once per day, and we were able to show that these messages, because they make it very salient what's happening in the background, makes the users aware of what's going on, are really effective at getting people to reflect on privacy and switch from their primary activity to privacy management. They actually go into the privacy manager and make changes. And that's something, when you talk to industry, they say, well, we have all these controls, no one uses them. Well, the reason is the information they provide is not actionable. So we're trying to make information actionable. And there's actually a whole design space about how we can more effectively communicate privacy as well as security aspects. And I'm particularly interested in exploring this in the context of devices that don't have displays or have very small displays.
what is the best way of then communicating this kind of information. A related strand of research focuses on analyzing privacy policies, because it's nice if we can come up with these more effective solutions for presenting privacy information or security information, but there are really not that many incentives for industry to adopt this. So what we looked at here in this project is how can we leverage crowdsourcing, natural language processing, and machine learning to extract data practices out of privacy policies. Privacy policies are these long documents we just saw that no one reads, right? And how can we then use that information, that extracted information, to on the one hand provide more effective privacy communication to users, but also inform, also analyze policies on a large scale and use this to inform public policy. And we conducted lots of experience on how we should crowdsource privacy policies, and one thing we found which is really encouraging is that if we set the thresholds, the agreement thresholds high enough, so we have multiple crowd workers look at the same piece of the policy, and we say at least 80% of the crowd workers need to agree, then what we find is they either agree, they either converge on an interpretation that's consistent with experts, or they don't converge. So that's kind of useful to determine whether we can use this information. I need to speed up a bit. And to facilitate more automated approaches, we recently released a corpus of 115 privacy policies, which are finely annotated with very fine-grained data practices, and we also launched a website that allows you to actually explore these annotations and get a better sense of the structure of privacy policies. And we're using this to basically facilitate research in natural language processing. So now when we can extract information from these privacy policies, we can do some really interesting things. For once, we can create machine-readable privacy specifications and then have devices communicate these specifications to user agents. And so the user can have basically a mobile app, for example, that reads information about devices in the environment and then provides options and information to the user and helps the user make decisions. And we can use the same approach the other way around and actually allow users to communicate their preferences to others nearby. So I'm giving a talk right now, and with this app you can actually say, like, I want it to be quiet, and then others see what the preference or the dominant preference is either on their mobile device or on some kind of public display. Here, the example of a train compartment. Another aspect I'm really interested in is using context information, context awareness, to automatically adapt privacy settings and privacy guarantees to the user needs in different contexts. So here we built a calendar display that you have in your office, and depending on who's in the office, it automatically adjusts what level of granularity and what information is shown on the display. And this also kind of shows how I approach research. I really try to deploy technologies and get them in users' hands, see how they act in the environment. And we can drive this further and help users actively support users in making privacy decisions. So this is in the mobile context, and we use kind of similar nudges as I showed you earlier to get users to make privacy settings, to change their privacy settings, and then we learn profiles from their privacy settings with clustering techniques. And then we can just ask them 3 to 5 questions to assign them to one of these profiles. Based on the profiles and the apps they have installed, we can give them personalized recommendations about which apps they might want to deny access to certain resources on their phone. And of course, this is still a pretty complex dialogue, but now I mentioned we leverage context awareness and basically spread this out and achieve more effective dialogue with the user. Okay, so that's my privacy research. In addition to that, I'm also really interested in interaction issues and techniques. So this is a study we did a while ago where we looked at how do people interact with broken displays and how does it affect their interaction with these phones. First of all, why do they continue interacting with the phones? This is a system we built for exploring volumetric data sets or 3-dimensional worlds. So it's a 7-degree display combination with a touch display at the bottom. We can also sense objects in there, and you see this game up there. The little knight falls down unless you place a little stair in its way, and then it can walk down the stairs, right? So it's kind of mixed reality aspects here as well. And then I think what's really important is to think about how we can support people in achieving their goals in better ways. So this is a system where we help people learn to play the piano. And we actually ran studies where we compared this approach to typical learning from sheet music as well as some other apps, and found that qualitatively, after just, I think, 2 weeks of training, the music they play is of higher quality with this system. We also build systems to help people find their wallets, for example. So this is kind of the surface of this, but what's below it is that we use relatively simple techniques, signal strength measurements and relative positioning to build low-cost indoor localization, which is typically quite expensive and requires extensive instrumentation of environments. And this is some recent work that just got accepted at CSCW, where we looked at the impact of assistive technologies on the communication quality between people with hearing impairments and people who can hear. And what we find is that depending on the technology, these technologies can actually emphasize the dominance of the people who can hear about the people with hearing impairments. And we proposed a different system called body sign that basically projects live interpret sign language onto the speaking person's body, and this kind of helps level the playing field. And we conducted an extensive Wizard of Oz study where actually people live interpret to see what is the potential of this technology. And yeah, that's the end. So what I'm really interested in doing going forward is I want to make UMSI one of the centers for the use of privacy and security. There are a few places, CMU is one of them, and I think UMSI can be one of them. And I'm particularly interested in aspects surrounding effective privacy management. How can we get away from privacy being this annoying thing you have to think about, or should think about, but never look at the settings, to something that just happens naturally as part of how you interact with technology, and particularly in the context of ubiquitous in computing and the Internet of Things. And yeah, there's this general theme of supporting people with technology that runs through my research. And that's me.
Okay, so hi, my name is Steve Oney. I have a background in computer science and math. So I'm originally from Michigan. I went away for college to MIT, studied computer science and math. After that, I went to Carnegie Mellon, where I did my PhD in human-computer interaction, and my focus is on usable programming tools. And after Carnegie Mellon, I spent a year here as a President's Postdoctoral Fellow, and this is my first year after transitioning to faculty. So my research starts with the assumption that programming is going to become increasingly important in many jobs. So you might know that the number of programmers has been rapidly growing, and right now there's an estimated 18 million programmers worldwide. And that number is projected to grow by 45% in just 3 years. But professional programmers are only the tip of the iceberg. There are substantially more non-programmers who aren't professional programmers, but do some form of programming as part of their job. So this includes things like writing complex spreadsheet applications or performing database management tasks. And they're sometimes called end-user programmers. They typically don't have a background in or a job description of programming. So as estimates of the number of end-user programmers have shown, most people who could benefit from programming skills will not be professional programmers. And this is something that I think is going to become increasingly true in the future, as more and more people have to manage digital information as part of their jobs. And as a result, my research focuses have been kind of threefold: designing and building new programming paradigms that better match the ways that non-programmers think about programming in their domain, improving existing programming tools, and enabling better programming education and support. So first, I've done several projects whose focus is on creating and designing new programming tools around the ways that we naturally think. So to give you an idea of what I would consider a success in this respect, look at mail filters. Mail filters are a form of programming where you give the computer a set of actions to perform and conditions, and it performs these actions if those conditions are met. But they're so well suited to the task that we often don't consider creating a mail filter a form of programming. So the programming tool that's suited to a particular domain is going to vary pretty starkly depending on the domain that it's being used in. And I've looked into designing new programming tools in 3 domains so far, which I want to mention in case it stirs up any interest, but I'm not going to go into detail on these. So I've looked at user interface programming tools that leverage several spreadsheet concepts to lower the floor of programming user interfaces. I've looked at multi-touch programming tools that provide more understandable representations for programming gestures on touchscreen phones and tablets. And I'm currently working on a project that's focused on improving web automation by allowing users to demonstrate tasks with the mixture of direct action and seeking help from remote crowd workers. But because we can't always design a new paradigm, we sometimes have to rethink existing programming tools based upon the usability needs of their users. So for example, previous research has shown that example code is crucial to helping developers, but typically example code lives on the web, like this example code for the CSS language on the left here. And this is completely separate from the programmer's editor, and there's no notion of which piece of code is example code here. So along with colleagues at Adobe Research, I developed something called Codelets that links snippets of example code, as you can see above here, with helpers or pieces of interactive documentation that explain what that example code does and actually will allow developers to customize that example code in a natural user interface. So this is a codelet, and I'm just going to show you a short video of what that looks like in action. So codelets allow programmers to have interactive documentation, and here in this codelet, a programmer can move sliders that customize the example code and draw arrows to indicate which piece of example code it's actually changing as well. Right? And in a user study, I found that codelets are effective in helping programmers both write code more accurately and faster, but also in understanding what pieces of example code do. So I've also looked at ways to design more effective help-seeking tools for programmers. And this is in part acknowledging that when even professional programmers aren't perfect, professional programmers, and to a larger extent, non-programmers who do programming tasks, need to rely on third-party help tools. Sometimes that help comes in the form of web documentation, but often the most useful form of help is another programmer. So the project that I'm going to show here is led by Yan Chen, along with Walter Lasecki and Sang Lee and CSE. And we're studying ways to make one-on-one programming help more scalable and efficient. So the question that we're asking is, how can we get the benefits of human personalized help without the coordination costs that are associated with going out, finding a qualified developer, and spending time with them? So we proposed a new help-seeking mechanism for programmers that uses asynchronous assistance. And in it, rather than having a synchronous one-on-one session with remote developers, developers can voice a request and send their request and work context to multiple remote helpers. And remote helpers can see these requests, and if they know the answer, then they can send back high-fidelity responses. And this is important because what this allows developers to do is to select a given response from a large selection of potential responses, rather than having a synchronous connection with one developer at a time. So we hypothesized that this form of help would be more scalable and more effective for developers because it allows developers to work on another task while remote helpers are assisting with their work. And to that end, we conducted several studies where we compared live synchronous support and asynchronous support, and we found that asynchronous support can be more effective because it's more parallelizable, so you can make a request, and because you aren't connected with the remote user while they're helping, there's less social pressure to stay on the same task. And we also found that developers can manage their workflow better by having fewer interruptions and waiting until they're ready to get a response in order to accept it into their code base. So again, I have three main research focuses: designing and building new programming paradigms, improving existing programming tools, and enabling better programming education and support. Thanks.
Hi, I'm not sure whether the mic is working. So I'm Michael Nebeling, and I'm also one of the new assistant professors here. I recently joined from Carnegie Mellon, basically where I was before. As you may guess from the accent, it's a bit weird. So I'm German, and I spent significant amounts of time in Switzerland. I was a year in Australia, and so my accent has evolved in different ways. But yeah, so that's me. What I'm doing here right now is actually I'm setting up a lab that I'd like to call the Information Interaction Lab, just to set the focus of what we're doing. And in summary, we are building or designing and studying the next generation of information interfaces. We are really interested in the methods and tools to create them. So currently I teach interaction design, and that's a lot of paper prototyping, and I like all these tools, but when we move to the more natural user interfaces that we work with nowadays, we need new methods and tools to actually design those and make this easy for a number of people. And I think the research that I'm doing ultimately allows more users to become designers, so by just lowering the threshold. And I have similar ideas here to what Steve said before, and I think there are good connections just between the four of us. And yes, I'm going to not show you statistics today, but yes, I could also talk to Michael. What I'm creating is something, it's an extended vision of a living lab. So the idea is really to involve everyone and to equip this room. Right now it looks like, as a concept, it looks like this. So my idea is to equip this lab as a space with the latest and smartest technology that we have today. And the point is really to show that even though we can put all these fancy devices in there, it's just not good enough, because and the way to improve this technology is not by adding more technology, but by adding people. That's the idea that we have actually behind. I'll show you a couple of interfaces today, and created this way. And the idea is to connect people to this room from the outside that can then help the people inside the room or inside the area where they're working to interact more naturally and in more interesting ways with the environment and the information in this environment. And so my research really relates to this whole research stream and area of multi-device environments. And I've worked in, most recently in a European research project where we really tried to transform a space like Lego or a design hub in Vienna into a more collaborative and more natural kind of interaction space. But I'm also really interested in this idea that nowadays users, us, we are actually multi-device environments. I'm not sure what's it like for you guys, but I came here with my fancy smartwatch and my mobile phone in the pocket, and I have a laptop here. And so this means that I'm by myself just a multi-device environment. And so I'm interested in actually creating these interfaces that can make flexible use of these devices. And so I wanted to show you, what I'm going to do now is I'm going to show you a couple of videos and research prototypes, and then I'll wrap up what the idea behind each of these is. And so one of the recent projects that I've been working on and that I will deploy in my lab is this cross-device web browser called XD Browser. So XD Browser has, it looks like a web browser that you're used to maybe, but it has this awareness of multiple devices, so the devices see each other. And as a user, without programming knowledge, what you can do is you can actually easily combine these devices. You can split interfaces between devices here for Gmail. You can access maps in a new way by looking at the same information but differently and synchronizing these devices. And you can just hijack a projector-based display like this one and control it with your mobile phone. And the fact here is that you don't actually have to download a specific mobile app for each of these examples. You can do all this just with a web browser. And so I'm really working on the technical issues associated with this, but also all kinds of design issues. And I'm going to show you a video that is, to be honest, confusing, but it also shows what I want to achieve in terms of the interaction. So I wanted to make it possible for users to quickly switch between these multiple devices, depending on the task. And so the devices here, a smartwatch and a smartphone, the smartwatch is not always great for input, but in some situations it's just easier to speak to your phone or to a smartwatch rather than actually type on the phone. And we have interaction techniques from these previous studies that we are now building into Android and other mobile operating systems that allow us to quickly switch between these devices. So here the user, depending on the situation, can actually then, just change the input modality by actually just changing between devices. And the last project I wanted to just throw into the room is, so these are what I refer to as cross-device interfaces. And an interesting way to build cross-device interfaces is by leveraging people rather than just combining multiple devices. And here we had a project recently presented at CHI, which was actually, it allows you to actually write an academic paper from your smartwatch. And the way to do this is not by coming up with new keywords or input and interaction techniques, but by building a bridge between the end user on the smartwatch and the crowd on more powerful devices. So this where-ride paradigm that I want to illustrate here quickly is behind the vision that I have for my lab, basically. So the smartwatch user on the one hand, he's the expert and he is the author, even though he's helped by the crowds that will then actually work on the writing tasks. So the author then provides writing tasks like introduction, I need a motivating sentence and something like this. And so these tasks then go out, and there's the crowd that works on established interfaces like Google Docs, and we help them through these tasks with our kind of, you see a little bit on the right, a new kind of crowdsourcing interface that helps the workers through these different writing tasks and feeds it back to the user. And so this is a paradigm that I'd like to, in some sense, do room scale. So what you will see when you come to my lab, when it's finally set up a month from now, lots of devices that are more intelligent than the ones that you can buy in the market. And the way we make them more intelligent is by actually putting people behind it. Like I did in where I can put a whole crowd behind a smartwatch and it becomes very interesting. We can have all kinds of new human sensors. We can have more effective ways of actually speaking and interacting with the technology. So the two research themes behind all of this is the natural user interface design, and here I want to make natural user interface design more natural, and both this means both the technology that we're using to create natural user interfaces, so where I want to experiment with more natural interfaces to information, and then create and study the natural user interface design methods, but also to make it natural for users to be designers, so allow more users to actually become. The way I achieve this is by making it easy and coming up with new interesting paradigms similar to what Steve argued about before. And then this other heavy theme is really this idea not to improve technology with more technology, but to improve technology with people. And so I'm building what I call human-powered devices or media, which is essentially augmenting existing devices with human capabilities. I want them to be smarter, human smart in some sense, and humans are really good at some things and not so good at others. So part of this research is also to see what are the good aspects of humans that we can leverage to improve technology. The goal is to enrich the interaction with digital and non-digital devices, because I can then start interacting with this wall, for example, by just leveraging a crowd. I could talk to a projected interface, the crowd hears me, I don't actually interact with it, but the crowd sees this, and so we can have all kinds of interesting interactive things. And that's the vision behind the lab, and that's I'm the last one, so I'm going to shut up now and we move on.
Okay, so I'll invite you guys to come up to the front after I pull up the screen and we'll open it to questions.
For Professor Schaub about making information more actionable and the context awareness. What are the different sort of signals coming in that you're able to process? What are you building to build that thinking?
Yeah, so that really depends on the particular domain we're talking about. So what I'm talking about is people, what are actually the potential recipients of information, Another big aspect is purpose. For what purpose is information used or collected? What is the user doing, the user activity? And there are probably other aspects we can look at as well. So it really depends on what is the particular context.
I think throughout all of your work, there's a general theme of leveraging people and remembering that people are always one of the ones behind the technology that we use, which I love. And I'm curious to hear more about your personal inspirations behind your work. What was the inciting event that made you start studying this? So it's a question for all of you.
Sure. So for me, a lot of, so my, I guess in my frame, I want more people to be able to program things. And I think the central insight behind that is that the percentage of people who are professional programmers is always going to be really small relative to the number of people who can benefit from programming. And those professional programmers aren't going to be able to anticipate all of the needs that people will have. You can come up with all of the options or interfaces in the world, but people will still have more ideas for useful programs. And so that's, I think, for me, the central inspiration.
I think maybe this isn't quite the question you're asking. If I'm thinking about a moment more, or maybe that's closer to what you're asking, I can give you a moment. In my undergrad, which was computer science, I got to, I think, like my third year, and I was starting to get kind of bored of the program. I mean, it had no impact, essentially, right? Like the stuff that we were talking about was not connecting to the world in some way. And I was taking a seminar course where professors were giving, a different professor each week would give a talk on their research to upper year undergraduates. And there was a professor in the department who I later went on to do my master's with, Michael Terry at Waterloo, who does human-computer interaction, and his work, he was taking his PhD work, so it was talking about like creativity support interfaces. So helping designers work through design problems and do kind of ideation and things like that. But that was a moment where I was sitting in a computer science classroom and I thought, this is actually something that's interesting, that's having some impact on the world, and that was something that actually led me to finish my computer science bachelor's, and then do a master's with him, and then that kind of struck me into HCI research afterwards. So that was kind of the moment where I think that happened.
Yeah, so for me it was kind of a journey. I started out studying in my undergrad computer science and media, which roughly translates to HCI. That's basically what it boiled down to, with a heavy computer science part of it. And but then I got really interested in security. And when I started my PhD, I started building security protocols and privacy protocols in the context of connected vehicles, car-to-car communication. How can we make this secure? How can we protect privacy? And then the more I started thinking about privacy, the more I realized, well, privacy doesn't make any sense without considering the users we're talking about. And I became more and more interested in, okay, what is the relationship between the technology, the user, the tensions with privacy and security, and what can we do to reconcile this in a meaningful way? And that's kind of how I embarked on this journey. And then this other aspect, in terms of supporting users, I think that really comes from a lot of the early UbiComp work. So looking at Mark Weiser and the idea of the computer disappearing into the background and kind of making way for the user to do what they want to do rather than being in the way. And I think a lot of us kind of do this, right? Like we all look at how can we make the hurdles of using technology go away to help you achieve what you want to achieve. And I think it's just nice to see that your research and work on actually has an impact and helps people.
Yeah, so I took a similar journey, but I must have taken a different direction, because I always say I leave security and privacy to the people that know, and that would be Florian in this case, and I'm really interested in exploring interaction techniques and interactive technologies without thinking in terms of the technical constraints. And one question that really drives my research right now is like, why do we have these devices? Why does the smartwatch look like this? Why does the mobile phone, which I have here, and why is it so difficult to grab it out of my pocket, but why does it look like this? And there's this problem that we can only do so and so much with technology right now, but is it really that people wanted this form factor? And then if you look at the evolution of mobile devices, I mean, they became smaller up to the point that you started losing them. Now they're becoming bigger again because, I don't know, that's just very interesting. And so I think part of my motivation comes out of frustration with current technology, and many of the research problems that I identified were really just out of personal experience. And it's also this other aspect. And when I started out in adaptive interfaces, there was this long research thread of adaptive interfaces. And people kept rejecting my ideas because they said it's all been done. But when I look at this state of the art in practice, there's still this really big gap. And so I think this is the other kind of aspect to my work, to bridge what we know in research and what we do in practice, and to bring these closer together.
Okay, so I've got a question, I think for Florian and Matt. So it seems like the problems of displaying statistics in an understandable way, displaying privacy policies in an understandable way are, at least should be somehow connected. I think it's a totally unfair question to ask you to go into detail on how that might be. But I don't know, did anything come out just from even just seeing the others work? Does anything come to mind? Of course, we should be showing better statistics in our privacy policies.
I can say that during my master's, I did some work on communicating software consent agreements. So certainly there's overlap because, or at least somewhere in my brain there was overlap because I was interested in both things. But articulating that might be a little bit more difficult. I mean, there's some element of here's a set of complex concepts that you're trying to communicate to someone in a way that is relevant to them and that they can understand. And I think that, for me, is the biggest overlap in those two areas.
Yeah, and I think there's also that aspect of uncertainty. Like how you communicate uncertainty in privacy or security mechanisms that do things automatically, or try to give you recommendations, what are these recommendations based on? So yeah, there's lots of overlap. We actually started, we already recognized that. Now we just need to figure out the $1 million idea.
Right?
Other questions for the speakers?
I have a question. Sorry. You talked about supporting people with technology, but and then you showed a video of a person playing piano and helping him learn piano with technology. So my question is regarding regarding which kind of age group do you consider? Because there is a certain age group which are not very comfortable with technology, even though I think they prefer to do it manually rather than technology. Also, there are a lot of technologies, and the technologies are coming up, hundreds of technologies are coming up as a days pass. So, how do you stay on top of it? I mean, yeah.
Yeah, I mean those are valid questions. The way I approach this is I don't try to come up with some technology that serves everyone equally well, right? So in the example with the piano, which we equipped with protection, we looked at novice piano players. Doesn't matter what age, everyone can use it. In my privacy work, I did studies with different user groups and age groups. So I did a preference elicitation study with seniors to better understand what are their privacy preferences and how can we support them. So it always depends what kind of problems we're looking at. And I think considering the user populations is an important part of defining the problem you want to solve. Because you're absolutely right, you can't just throw technology at people and say like, hey, this is cool, good, use it. right? Like, there needs to be a use case for it, and they need to have a need for a particular thing.
I have a question for Steve. So you were talking about like usable programming tools for programmers and non-programmers, right? So what's your take on forums like say Stack Overflow, which aid programmers? So are you trying to develop technology to replace that forums or something which assists them?
Yeah, so I think the project that you're talking about was the last project that I talked about, which was Ian project, which Walter is also a project leader on. So our goal with that is not to replace Stack Overflow. One thing that we found in a study is that there are questions that Stack Overflow is really good at answering. And there are some types of questions that Stack Overflow just isn't good at, like personalized questions, or a lot of kind of debugging questions, or requesting pieces of code. So we hope to be able to leverage Stack Overflow. I should mention, for those who don't know, Stack Overflow is a forum that has a bunch of programming questions. So it'd be great to be able to do things like mine Stack Overflow to get automatic answers for developers to be able to voice a question, and then you could either send it to another programmer, or if you can find this answer on Stack Overflow, then use that. But yeah, so it's supposed to be an addition for the types of questions that we found Stack Overflow isn't good at answering.
Question for Steve. What do you think about tools like If This Then That, or the iOS app workflow, in terms of enabling people to do this type of programming?
Yeah, so I think those are, so If This Then That and tools like Scratch are often in the domain of end user programming. You talk about low floors, or kind of a low barrier to usage, and high ceilings. So whether you can use a given language to program advanced things. So a lot of the tools like If This Then That, or Scratch, or things that have been widely adopted so far have been really successful because they have low floors. So one goal that I have is to raise the ceiling of these tools, because you can't program advanced concepts with If This Then That, right? So how can you raise the ceiling of tools like that without actually making it more complex to learn, or without raising the floor? So I think they're great. They need to work on, I guess, raising that ceiling.
One question.
I have a question for Steve as well. So actually two questions. So first question is that, I mean, there are a lot of tools which teach people how to program, but what about tools which can also help them debug more efficiently and understand what debugging is about? And the other question was that, I mean, in the same way, like how, like tools which can probably help them program within something like the terminal, and navigating their way through.
Right, so yeah, so for the first one, for debugging, I haven't looked at debugging tools. I do think they're really important. Some people have described programming as debugging iteratively. So that's something that I haven't looked into. There is a body of research on that we can talk about offline as well. And then with respect to, I guess, teaching low-level kind of terminal programming, I personally don't think that many people will need to learn programming through low-level tools or low-level languages. I mean, there's a lot of computer users that haven't even seen a keyboard, and I would say that most computer users probably haven't seen a terminal. I think programming tools can get higher and higher level. There's always going to be a need to have low-level languages and low-level tools, but I think it's going to remain kind of a small percentage of people that need to do that. I don't know if that answers.
No, it does give some clarity. And I understand what you're saying about it getting higher and higher, but people not probably venturing into at least people who are looking to
Yeah, there are a lot of, I think for people who are learning to program themselves, that kind of will add a lot of learning and conceptual barriers. Learning low-level language or low-level tools rather than a high-level language. Yeah, we have to talk about it more.
Great. Let's thank our presenters. So for next week, we have a guest speaker, Justin Lingle from University of Pennsylvania. There'll be a reminder and a spreadsheet that will be sent out if you are interested in meeting one-on-one with her as well. So keep your eyes out for that. So thank you, everyone. See you next week.